Hello, this is Ken McCrate, and we're going to go over this problem here. This is one of our test problems. And what I've done is on our test, this dimension right here is actually shown up here at the top. I just moved it down here onto this plane so that you don't mistake it for this tangent edge here. And the other difference is they give you a radius from this point to here, and I've just put this 1 inch 250 thousandths from here to here, which comes out to be the same because the radius comes all the way around this piece, all the way to where it becomes tangent with the other piece, okay? So without further ado, let's take a look at what we have going on. So the first thing I want to do is I want to find this angle here. Why? Because that's the things that I actually have. So I want to find out what we get for this distance right here. And we have two sides, so that helps me to solve for that. What's that going to do? Well, when we're looking at this, we want to solve for x eventually, right? So this is what we're getting to. So if I knew what this angle here is, that would help me to solve for things if I could figure out some other things in here. Now, what we also know is that we have 1 inch 250 thousandths from here to here. That's going to stay the same all the way around, right? So this radius swings all the way around, it's going to stay the same. So we know that we've got that here, but this isn't at a 90 degrees anywhere in here, so this is going to be a little bit different in what we do. So that'll be the next angle that we try to figure out. But for right now, I need to come up with a angle here. And if I can find this angle here, then what I'm going to do is I'm going to subtract it from 35 degrees. And that'll tell me what this is here. Okay, so what I've done is I've taken the opposite side over the hypotenuse side. Okay, so this is where the angle that is that we're looking for. So that makes this surface over here the opposite side, right? And the hypotenuse is the longest side of the angle, and it's also directly across from the 90 degrees. So that's 4 inches, so we know that that's what we have there. So 1 inch 250 thousandths divided by 4 equals the sine of that angle. So to get that, you're going to take 1.25 divided by 4, and then hit your invert sine key. So when you do that, you're going to get 18.2099 degrees, decimal degrees. Then what we're going to do is take this and subtract it from 35. So we have 35 minus the 18.2099. So I'm putting that in right here. All right, now let's take a look at the next piece. So when we use the law of sines, the actual formula or the theory behind that is that in any triangle, the sines of an angle are always proportional to the lengths of the opposite sides. So what does that actually mean? The sines of the angle. Well, here we're looking at 16.7901. The sine of that angle is proportionate to the opposite side. So that's the one that we're looking for. So in that sense, what we're going to do is we're going to take this 16.7901 and multiply it times this length and this opposite side over here. So here's your opposite side, okay? Here's your opposite side. It's proportional to the opposite side, so that when we go to solve this, we're going to divide that by the 1 inch 250 thousandths. And the formula is set up like this. So what does that mean? Here's your actual formula. And that means this. If we're looking for this, which is C, I'm going to put this down as C. This is related to this. This is the 4 inch side, remember? So this is related to this as this is related to this. So again, what we're looking at is this surface here is to this angle as this surface here is to this angle. So what we're looking at is the side, or the known side, times the sine that we know over the side. So that breaks it down to 4, because we're looking for C. Okay, so that would be here if we had to put that down. So 4, we have 4 inches, that's this length here, times the sine because it's related to this. So this is to what would be this angle, as this would be, this sine is to this side. Okay, now how do I say this again? So if we had angle C here, 4 is to C. Now I don't want to put this here because that doesn't belong there in the formula. That's not the way that it's written, because see, you see the sine here, it's the side here, it's the side here. But just so you kind of get the idea, this is to this what this is to this. We know what this is. This is this, 16.7901, and that's related to this, as this is related to this. Okay, so you put them like that. I hope that makes that pretty clear. I think that's pretty clear. So again, one more time. This surface, or I should say this surface here, which is 4 inches, is related to this angle, as this 1 inch 250 thousandths is related to this angle. Now the C doesn't belong here. I have this here just so that you can kind of see what's going on with that. So I'm going to put this circle around this thing like this and put a hash mark through there like that so that you know that that really doesn't belong there. Kind of, you know, like the no sign. Okay, that really isn't there. So 4 is to the C, 4 inches is to this angle, as 1 inch 250, which would be this here, is to this angle. So we know 4 times sine of 16.7901 divided by 1 inch 250 thousandths. Okay, so let's go ahead and do that. Okay, so I do want to make one correction here. Remember what I said, the side, and it's good that I wrote this down, the side is to the sine as the side is to the sine, right? So the 4 is to this angle right here, which is the 16.01. Now see, if you notice this, this is above this angle right here, right? This is above it here. So this side here, which is the 1 inch 250 thousand, has to be above it, not inside it. Okay, so not inside, has to be above it. So that's the only correction I want to make. It was still the same formula, just that I had when I sketched this up. I sketched it up too quick and I didn't put this in relationship to. That's why it's good to write these things all the way out. So again, the side is to the sine as the sine is to the side. Okay? The side is to the sine as the sine is to the side. So this, since this is above this angle, has to relate to this angle, since this is the angle I'm looking for, above this angle. And if you work this out, I'm going to work out the numbers again. So working it all the way out, 4 times 2.888, because that is the decimal equivalent of this. So you take 16.7901, hit the sign key, you're going to get 0.2888. So 4 times 0.2888 divided by 1 inch 250 equals 924 3/10. Then hit your invert sign key, and you're going to get 67.5734 degrees, decimal degrees. That's what you get here. Now, we got to solve for this, right? That's what we're looking for. So how do you think you're going to do that? Well, it's really, really easy. Do you know what this hypotenuse is here, this long side? You know that if you drew a line straight down, you'd get a 90 degrees here. Do you know what this angle is here? So what you want to do is solve for this leg right here, or solve for this leg right here. It doesn't matter which one you do. And we want to first solve for the overall leg, which is from here to here. So we know that if I took this and stretched this all the way down here like this is what I'm looking for. I'm looking for this side right here. I know I have a hypotenuse of this green angle of 4 inches, that's that there, and an angle here. So what am I looking for? Why not save ourselves some time and solve for the adjacent side? So when we're going to solve for the adjacent side and we have the hypotenuse, what are we going to use? So here's what I have. Adjacent over hypotenuse equals the cosine. Adjacent over 4, because the hypotenuse is 4 inches, equals the cosine of 16.7901. The cosine of 16.7901 is 957 3/10. So the adjacent side equals 4 times 957 3/10. If you take 4 times 957 3/10, you're going to come up with a size of 3 inches, 8294. So that's what I have here, okay? And I have this in black over here. So this should be in black here too, but I don't like the color green. It doesn't show up as well. So I wanted to do the numbers in black. Now you have that. You also know that you've got this angle inside here. This angle inside here is 67.5734, right? And you know that you've got 125 thousandths here, right? Or 1 inch 250 thousandths, I'm sorry. 1 inch 250 thousandths here. And you've got this angle here. So what are you going to do? You're going to solve for this opposite side. When you solve for this opposite side, just take this opposite side and subtract it from this, and you're going to get that. And there's your answer. Okay? I hope that helps, and we'll see you on the next one. Take care and have a great day.